Good morning, all of you. Thanks for joining this session. I'm sharing my screen. Please, any one of you confirm whether I'm audible and my screen is visible or not in the chat box. Okay, I assume that my voice is audible and my screen is visible. Let's begin our session. So briefly, I don't want to waste much time on the course description, but some of you may not be knowing what it is. Docker and Kubernetes is our course. Docker and Kubernetes. The course duration is 45 days. And I know some of you are not happy with this 45 days, but our motto is to learn, not time. So duration of the course is 45 days and classes will be from Monday to Saturday. Monday to Saturday. Monday to Saturday. Anyway. Then class timings are 6 a.m. to 7 a.m. IST. 6 a.m. to 7 a.m. IST. You will get live classes plus recordings, live classes plus recordings plus class notes. Okay. And course fee is 4,000 INR. Duration is 45 days. Many of you are not happy with this 45 days because you may see that the entire DevOps course is being done in 45 days from some of the faculties. But here, Docker and Kubernetes, we are learning specially and we will be learning it intensively and extensively in real-time perspective. So there is no compromise on the quality. So that's the reason the duration is a little longer. The classes are from Monday to Saturday and timings are from 6 a.m. to 7 a.m. IST. You will get live classes and recordings in Google Drive and notes in the Google Drive. Fee is 4,000 INR. This is the course description. And this is our first class. Even though it is demo class, this is going to be our first class and we will be eligible for free classes for next 3 to 4 days. After that, link will be changed and new link will be shared to those people who have paid the money. And coming to the notes, I have the notes of Docker and Kubernetes, which is prepared by me. And Docker consists of about 65 pages of notes, and whenever necessary we will be moving to official documentation also. Okay, so this is the Docker notes and you can use this in your real-time projects. Then coming to Kubernetes, we have about 100 pages of Kubernetes notes and all these notes I will share to you. Okay, exactly all my notes I will share it with you. Okay, and whenever it is not just 100 pages of notes, whenever necessary we will be switching to official documentation also, and all these notes will be given to you, right? So considering all these facts, I can say that the course is value for money. Now let's begin our first class. And the important thing to note is the prerequisite to learn Docker and Kubernetes is nothing. You don't need to have any knowledge. You don't need to have any cloud knowledge also, but it is better that you have some AWS knowledge. You have some idea about basic Linux commands. Even if you don't have that, that is well and good, because whatever the commands, whatever the services that we are using in the AWS, that things we are going to learn as part of this course. Okay, So you don't need to have any pre-knowledge to learn Docker and Kubernetes. Got it? So having said this, now let's move to the actual class. So whenever we are talking about Docker and Kubernetes, we are talking about containers. We entered into the world of containers. What is container? Container is an empty box. And if I show you container, you will be surprised. See, these are the containers. This is the container. And these containers will be carried by the cargo ships over the seas and oceans to transport the goods from one location of the world to the other location. And these are also containers. Containers means which contains something. And see, this is a container. This is the container actually we will be having in our minds. So this is a cargo ship which is carrying the containers from one location to another location over the seas and oceans. Okay, and this we will discuss going forward. And containers are everywhere. Containers are everywhere. In road transportation, we have containers. If you see, if you are going on highways, you will see trucks carrying those boxes. Those are nothing but containers. And containers are being carried by the airplanes also. Means the containers are used in airways. And no doubt that in goods trains, the containers will be carried and containers will be having what? Some goods and material like steel, iron, coal, and all those things will be carried in the trains using the containers. What is the benefit and why this term containers is adopted in the software industry? All these things we will learn very thoroughly, right? Now, before going to that, if you know the philosophy of Plato, Plato in his philosophy has said that necessity is the mother of invention. I think it is Arial. Necessity, necessity is the mother of invention. Okay, who said this? Plato. Plato is an ancient philosopher. Necessity is the mother of invention. That means man has invented everything that exists now because of its necessity. Computer was invented because there is large scale need for high computation speed. For that, computer was invented. Imagine our life without calculator in business and commerce. Imagine our life without computers. Because of the necessity of the time, these things were invented. Initially, the human being was wanderer. He was roaming. There is no settled life. But later, with the increasing the population, there was a need for settled life, and there was a need for to invent the agriculture to meet the growing requirements of the food demand. For that, agriculture was invented, and in agriculture, different tools were invented to optimize the resources. Like that, the software industry came up with the concept of containers because there was some problem the industry was facing. To overcome that problem, the software industry came up with the concept of containers, right? So what is container? Why they were invented? How it has solved the problem that existed? All those things we will discuss. Now, what was the problem that the industry was facing? The problem was, now let's suppose that the software industry has to develop an application, and it involves many steps, and that is called as what? Software development life cycle, SDLC. It is called as what? SDLC, software development life cycle. And this SDLC cycle starts with the development of source code. It starts with the development of source code. For this, a team of experts called dev team. Okay, dev team will be there. Dev stands for development. It is the responsibility of the development team to develop the application. When I say developing the application, writing up the source code for that application. Once the source code is developed, it has to be deployed into the servers. But let's suppose that this dev team consists of only single developer for simplicity. Now, when that particular employee joined the organization, he will be provided with a laptop generally installed with Windows operating system. Okay, so this guy is provided with a laptop which is installed with Windows operating system. Now, once he is into the project, and there are some projects where the developer is needed to have Ubuntu operating system. In that case, what software industry used to do was, because the need is to provide Ubuntu operating system to the developer, they will buy a new hardware. They will buy a new hardware from the vendor, and they will install Ubuntu operating system in this machine. What they have done? Initially, they have given Windows operating system to the developer, but after he is entered into the project, there was a need for Ubuntu operating system. And for this, what software industry used to do was, it has to buy a new hardware and install Ubuntu operating system. And in this case, the same employee or the same developer is provided with two machines. And imagine if we have 100 people, imagine if we have thousands of employees. This is very cost burden. To overcome this, a tool was invented, that is hypervisor. So the concept of hypervisation, virtualization was invented, and in that a tool was installed that is called as was Hyper-V. So from here to Hyper-V, what is the virtualization? What is the advancement? Okay, so the advancement is that here we have two machines, but if we use hypervisation, if we use virtualization, what we can do is, within the same host where Windows operating system is installed. Now let's suppose that the capacity of this hardware is 16 GB memory. Memory is 16 GB. Okay, Now let's keep aside disk and CPU. Let's concentrate only on memory. And this is a machine that is given to the developer where Windows operating system is installed. In this, Windows operating system is installed. Now, what earlier used to do, because the developer needs Ubuntu operating system, a new hardware was purchased, and in that Ubuntu operating system is installed, and that machine is also given to developer. So that is double cost, and it is very hard to maintain two systems. Now, with the concept of virtualization, okay, so what virtualization will do us, the virtualization, the tool we will install is Hyper-V, hypervisor, and one of the most famous hypervisor is Hyper-V. Hypervisor will enable us to install guest operating system in the same hardware. Okay, so here we have Windows operating system, which is called as what? Host operating system. And within the same hardware, the hypervisor is enabling us to install guest operating system, and in our case, it is Ubuntu. In our case, it is Ubuntu. And we have different kinds of Ubuntu operating systems, and we can install any of them. Now this OS is called as what? Guest operating system. Guest OS. This is host OS. This is guest operating system. And you can install as many number of guest operating system as you want, provided that you have sufficient system memory, CPU, and hard disk, right? This hypervisor is enabling us to install multiple operating systems in the same host machine. Here we can install Ubuntu, here we can install CentOS, here we can install Mac. So different operating systems can be installed in the same host machine, provided that there is sufficient system resources like CPU, memory, and disk space. Okay, so from earlier situation to this hypervisor, see how much benefit we got. Here we have optimized the system resource utilization, and at the same time we have cut the cost at least by half. Earlier we used to have two systems, one for Windows operating system, one for Ubuntu, but now the Ubuntu is also installed in the same hardware where your Windows operating system is running. Now, but here too, now once this is provided, what is the next step? So this developer will start developing the application. This developer will start developing the application, and to develop that application, some dependencies have to be installed. Okay, let's suppose that is going to develop application A, and that application A will require libraries, right? For example, if you want to develop Java application, JDK and other requirements are needed. So now here, now let me call them as libraries in general. So you may require multiple libraries to develop and run this application. Okay, and this is Ubuntu operating system 18, and you may need to develop and run another application called application B, and for that you may require different set of libraries, and here you may require Ubuntu 20. That can be easily done. Okay, here we can run Ubuntu 18 operating system, and in another instance you can run Ubuntu 20 operating system. This is the beauty of virtualization. But here, okay, I will come to that point later. Here, let's focus on application A. This application A has been developed, and preliminarily the developer will test this application in his local machine, and he will ensure that it is properly running. Once that is ensured, then the application source code has to be stored in some central servers called as repositories. In short, they are called as repos. For example, GitHub is the famous one. Now, we have to store this source code in the repository. Now, we are pushing the source code to repository, in our case GitHub. So now the application A, that means the application A's source code is now saved in the centralized repository called as GitHub. Then what is the next step? The next step is to test the application. To test the application, we have testing environment called QA. So the application has to be deployed in the QA environment. And to deploy the application here, again, what we have to do? We have to install the necessary libraries, and after that, we have to install this application here. And here, there may be number of libraries. For example, generally we may require about 6 to 7 libraries. Okay. Now, once this is installed, now the QA people will start testing the application by using various tools. Now they will say that the application is not running in the QA. They will raise a ticket, they will raise an objection that the application is not running as expected in the QA environment. And please remember that the application is successfully running in the dev machine. The same application is deployed after installing the libraries and the necessary operating system here. But why this is failing here? The same application is successfully running in the dev machine, but why it is failing here? What can be the reason? So because of this failure in the QA people will tell that the application is not running, but dev people will tell that please come and see in my machine it is successfully running. It is the problem with the QA. So there is a firefight. There is a firefight happening between development team and testing team. Developer will show that the application is successfully running, but QA people are reporting issues. What can be the problems for this? Why the same application, when it is deployed in the QA environment, it is failed to run here? The reasons can be, one is operating system. Ubuntu 20 here. Here the operating system was Ubuntu 18, but in QA the operating system is different. Here the same operating system with a different version. So this may be the one cause for application failure in the QA environment. So noticing that what we can do is the infrastructure engineer may uninstall this Ubuntu 20 and install Ubuntu 18 in the QA environment. Now, what we are doing? We are changing the operating system here to 18. Now, the operating system we have installed is 18, which is same as that of the dev machine where the application was successfully running. But even after doing this, after installing Ubuntu 18, we need to install libraries again. But even after installing the same Ubuntu operating system in QA, still the application is failing. What can be the reasons? The reasons can be, even though we have installed the libraries, one or the other library may be missed installation here, maybe missed in the installation here. Let's suppose that we need to install 8 libraries here, but here one is missed. We have installed only 7 libraries. That may be the reason for application failure in the QA environment. And later, we noticed that that particular library is missed, so we will be installing that library also. But even after doing that, still the application is failed to run in the QA environment. Why? Why? Because even though we may be installing all the libraries that are installed in the dev, but the libraries version may be different. For example, here they may be installing Java 8, but here we may be installing Java 11. So like that, different versions of the libraries are installed in the QA. That may be the reason for application failure in the QA environment. So even after installing all the same versions of the libraries that are installed in app, still due to infrastructure issues or due to another issue, there is always a possibility for the application to be failed in the QA environment. So it is very hard to achieve the same environment as that of the dev. That is the bigger challenge here. Okay, so we need to do all these tasks even after trying hard to install the similar kind of operating system and similar kind of libraries with the same version. It is very hard to make the application successfully running in the QA machine. So this is a challenge. And if it is running in single instance, what if this single instance is down? There is application downtime. Okay, so these are all the challenges that are there in this kind of setup. Okay, now this is application A that is deployed here. Now imagine a situation. These are all the challenges. Now imagine a situation where along with the application source code, we are also packaging the libraries. Okay, imagine a situation where along with the application we are also packaging the libraries and installing the same thing here. Okay, So now what we are doing, see, earlier the challenge was it is very hard to install the same kind of libraries. But now in this setup, what we have done is, along with the application source code, we are also packaging necessary libraries with the application source code itself. And we are packaging the application and libraries in a file, and we are shipping that file from the dev machine to the some central server, and from there we are deploying it into the QA. And this kind of setup is called as what? Containerization. What we are doing is we are containerizing. We are putting the application and the libraries, we are putting or we are binding or we are bundling the applications and the required libraries in a box, and this box will be carried from one location to the other, from dev to central server, from central server to QA, and if it is tested properly and if all the test cases are passed, then the same box will be deployed into the staging environments, and once and it is done here, then it will be deployed into the production environment. Okay, so what we are doing here is, if the application is successfully running in the dev, it should be successfully running in the QA machine also. Why? Because we are deploying the same application and same set of libraries are carried to the QA here. We don't need to install here afresh. The same libraries are shipped. The same libraries of the same versions are carried to the QA environment. So there is no scope for failure. But of course, this operating system version doesn't matter in this setup that we will see later. And if it is successfully working in the dev, it will successfully working in the QA. And if it is successfully working in the QA, they will give sign off and it will be deployed into the staging and then after in production. This is called as what? Containerization, and this is what we will learn in Docker and Kubernetes. Docker is a containerization platform using which we will achieve this kind of packaging of the application along with its libraries. And Kubernetes we will use to orchestrate these containers, to manage, to automate the deployment, packaging, and networking and scaling of the containers, and that is called as what? Orchestration. For orchestration, we have a beautiful tool called as Kubernetes, which is developed by the Google and which was made as open source since 2014. Got it? So this is what we will learn in Docker and Kubernetes. Then how to containerize, how to shape, how to deploy, all these things we will learn in this course called Docker and Kubernetes very thoroughly. Got it? Now, before understanding that, now here let me draw the earlier setup and this setup earlier we have what? Hypervisor. I will copy the image from my notes. Let's play with this in Paint. So if you see here, earlier we have infrastructure, that is hardware, and we have installed Windows operating system, and in that we have hypervisor. This hypervisor is enabling us to install multiple guest operating systems. Got it? And here, this is application A running in one of the guest operating system. And here, this is Ubuntu, and the necessary libraries are installed here. But here the problem is that when we are installing the guest operating system, we need to dedicate the system resources upfront for that particular instance. What does it mean? For example, we have 32 GB of memory, and when we are installing this, we need to keep aside, let's say, 4 GB of memory to this, and that 4 GB of memory will be dedicated to that particular instance. Whether this instance may be using it or not, but that 4 GB of memory will be dedicated to this upfront. And the operating system that we are installing in the guest operating system is as heavy as if we are installing that Ubuntu operating system in a brand new hardware. What does it mean? For example, if you take an hardware, an empty laptop, and in that, if you are installing Ubuntu, how you will do? We are not installing Windows, we are installing Ubuntu. So for that, what we have to do? Ubuntu OS. So if you go to this Ubuntu official site, you will see that the Ubuntu image, the Ubuntu ISO file size will be about 2.3 GB in size. So when we are installing it in a new hardware, you have to download and install, and here also you have to install the 2.3 GB of operating system. So that is very heavy. And if you are installing another operating system that may be about 3 GB in size, and to just install the operating system, it will consume many much amount of the system resources. We have allocated 4 GB to this. To install the guest operating system, some memory will be consumed, and after that only a little amount of memory will be left for actual application running, right? But if you install this setup, here we have infrastructure and we are installing the host operating system. In real time, we will be using Ubuntu operating system as a host for Docker. Then we have to install Docker in this. So earlier there was a tool called hypervisor, but in case of containers, we will be installing a tool called Docker. And using Docker, what we are doing? We are running containers. And containers you can think of as virtual machines. But from here to here, what is the difference? The difference here is, here we have installed full-fledged operating system, but here we have eliminated the need for installing full-fledged operating system. But if there is no operating system in this container, how that application will run? That's a good question. In case of containers, the containers will be utilizing the underlying operating system kernel. The containers will be utilizing the underlying operating system kernel, but this is not the case in case of hypervisor. Every instance will be having its own full-fledged operating system that is very heavy. But in case of containers, see here the instance will be having a load of minimum 2.3 GB, but here see that 2.3 GB load is removed. Instead, the containers will be utilizing the underlying operating system. Here the containers are nothing but what? They are instances. They are Linux machines only. You will see that going forward. Okay, but here to here, see, we have eliminated the need for installing full-fledged operating system. And one thing is that here we can push only source code, but here you will see that along with the application, we will also ship the library. Okay, and that is the thing. And how many containers we can run? We can run as many containers as we want, provided that there is system resource, sufficient system resources are available. Here, we have dedicated the system resources upfront. For example, out of 32 GB, we have allocated 4 GB of memory to this particular instance. But here, there is no such requirement. We don't need to dedicate the system resources upfront to the containers, but instead, containers will be utilizing the resources from the host. We are not dedicating in advance. Okay, and of course, we have a mechanism to reserve and to limit the utilization of the resources by a particular container that we will see during the course. Got it? So, and what is the advantage of eliminating the installing the full-fledged operating system in the containers? One is that the load is decreased, and that makes the containers very lightweight. If you take the size of this image is about 3 GB or 2.3 GB as we have seen from here, but the size of containers is very minimal. It is generally sometimes below 100 MB. Where is 2.3 GB, where is 100 MB? In some cases, it is just 2 MB inside. That makes the containers are very lightweight and very super fast. They will be booting up very fast. Okay, so that's the reason. So if you want to install this and if you want to bring up this virtual machine in case of hypervisor, it will take at least 30 minutes. But to bring up the containers, it will take just 1 or 2 seconds. Where is 30 minutes? Where is 1 or 2 seconds? Imagine. So that fast are the containers. Containers are very super fast. So when we are deploying, when we are scaling, and when we are bringing them down, all these things will be happening very swift. All these things you will witness during the course. Okay, so this is now what is the advantage of the containers here? For that, I will tell you a story from the shipping industry. Let's suppose that there is a ship, there is a cargo ship which will carry this is not the passenger ship, passenger ships will carry the people, okay, but cargo ships will carry the goods. Now, let's suppose that this is a ship. I'm representing the ship with this image, with this drawing. Now, there is a ship owner for this. Now, there is a customer here. Customer. And the customer requirement is that he wants to transport 3 tons of fish and 2 tons of raw material. There is a customer who was in need of transporting 3 tons of fish and 2 tons of raw material. What this customer will do is, this customer will come to owner, ship owner, and tells that, hey owner, I have to transport these 3 tons of fish and 2 tons of raw material from, say, Chennai port to Sri Lanka. Okay, or some Chennai port to some Maldives or some other port. Okay, some Vizag port. So in that case, what this owner will do is, owner will charge some money And what this owner will do is he will keep the 3 tons of fish like this in the ship. So I'm telling the things which are used to do in the ancient times, not in the modern times. Okay, so this is the 3 tons of fish. And and for fish, what is needed? The fish has to be put in the ice. Okay, the ice has to be put first, and in that ice, the fish has to be put in order to avoid the spoilage. Then, where this raw material will be put? The raw material will be put something like this. This is the raw material. So, raw material can be anything. This may be a feed for the fish or any other raw material. Okay, so the raw material is put like this. And you know that the raw material should not be mixed with the water or ice. Otherwise, it will spoil. Now, what we'll be doing is that this ship will be in transit for hours and in some case for days. So the ship has to travel over the seas and the oceans. And we know that the oceans and seas are not calm. They are always wild, sometimes wild winds, wild waves, and typhoons and tornadoes. All those things will come. And during that time, there is always a possibility that the fish and the raw material will be mixing together because there is no proper compartmentalization here. There are no compartments. So this thing used to do during the ancient time where the shipping industry was first began to flourish. So there is a possibility that the fish and the raw material will be mixing together. If this is the case, what will happen? Fish will be spoiled and raw material will also be spoiled. This is the setup. Now, slowly, when the shipping industry is being developed, when it is in development phase, later, what they have thought is that instead of arranging the material like this, let's keep that aside. And now let's delete this. What they have done is they have invented the containers. Okay, now let's see that. What they have done is they have made empty boxes of equal size. They have made empty boxes of equal size. This is one box. This is another box. This is another box. This is another box. They have made empty boxes of equal size. Now let's suppose that if the capacity of the ship is 100 tons or 10 tons, now let's suppose that, so they may be creating 10 boxes of equal capacity, like 1 ton each. Now what they do is, so for fish, we need to have ice. They will put ice in this particular box called containers. These are called as what? Containers. So they put ice in this and they put the fish in this particular box. 1 ton of fish is put in this, and in the next box, they have put another ton of fish. And in the third box, they have put another ton of fish. So total 3 tons of fish is put. And for raw material, there should be a dry atmosphere. There should not be ice in this. So what they have done is they have put the raw material like this. 1 ton in this box, another ton in this box. Now, what they have done is they have arranged these boxes inside the ship. Now see how beautiful it is from here to here. There is no possibility of mixing of fish with the raw material because they are they are completely isolated. They are isolated from each other in the boxes. This is there in this box, this is there in this box. So there is no possibility of fish mixing with the raw material, and there is no possibility of fixing the mixing of fish with the fish which is there in the other containers. Got it? So even if the travel duration is hours or days, there is no spoilage of fish and the raw material by mixing. Got it? So same like this, the same analogy is there in the our software containers also. You can imagine this this application as this fish as the Java application, and the ice as the libraries, and this as the container. So in the container we have both the application and the libraries. This is one Java application, and we are running another Java application which may require different Java version. Okay, here it is Java 8, here it may be Java 11, and this is different application altogether. This is Python application. Okay, so this is how using containers the applications are isolated, and they are isolated in the aspects in which they have to be isolated, but they are sharing the same system resources. They are sharing the common resources. They are all sharing the same memory. They are sharing the memory and CPU from the same hardware, right? So the applications are isolated so that there is no process interference, there is no conflict of the uh, different versions. Here in this setup, we can run multiple versions of Java. Here for this application, we can run Java. We can run the application which requires Java 8 using this container, and we can run another application which requires Java 11, and we can run Python application, and we may uh, here we may require Python 2, and here we may require Python 3. All this is possible with the concept of Docker and Kubernetes. Got it? Of course, Kubernetes for orchestration of the containers. Then tomorrow we will continue what is Docker, what are different terminologies that are associated with the Docker, how to install Docker, how to run containers. All these things we will learn thoroughly. Got it? So I just want to give you the course details again for the people who have joined the late. The course name is Docker and Kubernetes. So already the institute people have pinged all these details in the chart. If I'm not wrong, they have also given the phone numbers where you can pay, where you can contact if you want to subscribe to the course Docker and Kubernetes. The course duration is 45 days. Classes are in weekdays. Okay, days are from Monday to Saturday. Timings 6 a.m. to 7 a.m. It is Indian Standard Time, friends. And course, what you will get is live classes plus recordings plus what? Class notes. Not class notes, it is entire notes. Then course fee is 4,000 INR. Now, if you see, my notes will contain about 65 pages of Docker, and not just this 65, we will be moving to official documentation whenever necessary. And our Kubernetes consists of about 100 pages of notes, and we will be moving to the official documentation wherever necessary. And we will do all the courses practical. Okay, all these things we will do practical things, and you can use my material in your real time also. Okay, and I will teach how to install Kubernetes in AWS, how to install Docker in AWS Ubuntu machines, and we can see how to interact with it and all those things. Even if you don't have AWS knowledge, that is fine. So we will learn those particular things in this course. And if you are using Azure, the same installation of the Kubernetes is different everywhere. Same steps, same commands will be there either for Docker or Kubernetes, irrespective of the platform or irrespective of the cloud that we are using. Okay, you don't need to worry about it. Got it? So that's all for today, friends. If you have any questions, you can ask me. Otherwise, we can wind up this session. Thank you. I think no question. If you have any questions regarding the course fee, when to pay and all, and you can call the phone numbers that they have given in the chat box. They have also provided the phone pay numbers and all. And and for the first 3 or 4 days, everybody is eligible for the classes. And after three days, the new link will be coming, and that new link will be shared to the people we have paid the money. Okay, so those details will be told by the admin people, the institute people. I'm just reminding it one more time here. Got it? And every day's recording will be uploaded on that particular day by afternoon. For example, today if the class is done at this time, by afternoon the recording will be uploaded to the Google Drive, and they will be sharing the Google Drive with you. And in case if you are not able to attend the class on that particular day, you can go through the recording, and there is no doubt that you will understand it without joining the class also. Okay, so my teaching style is something like, I will know the doubts that you will be getting, and I will be into your shoes, and I will answer that. Like that, it will be done. Okay, most probably that is the teaching way, and you can use these notes and all. How the course structure is Docker and Kubernetes in parallel? No, they are not in parallel. For Kubernetes, the prerequisite is Docker. Without learning Docker, you can't learn Kubernetes. First, Docker will be taught. Then after that, once this is done, Kubernetes will be started. Okay, but it is necessary that Docker is must for understanding Kubernetes, because Kubernetes will orchestrate the Docker containers. Docker is must for Kubernetes. Yeah, and these days developers also need to learn Docker and Kubernetes. Okay, it's not just DevOps engineers. Docker and Kubernetes is also for developers in order to understand the microservice deployment, the logging system, and everything. So developers and even for testing engineers also, Docker and Kubernetes is very necessary. Even if you see the job descriptions, there they will mention definitely Docker and Kubernetes in one or the other, and CI/CD tools also. Because if you give Jenkins to the QA people to deploy, at least they should know how to how to trigger the pipelines. So all the DevOps tools are necessary for the uh, testing and developers also these days. Okay. Anyway, thank you guys. Let's meet tomorrow. If you have any questions regarding course, you can ask me now itself, and otherwise we can wind up. Thank you. Let's meet tomorrow at the same time. Thank you all.
Thank you all.
Okay.
Thank you.